Hello, and welcome to Engineered Wetlands and Applications by Desmond, Natsumi, Nathan, and Sydney Wilson. Engineered wetlands are a man-made version of a naturalized wetlands landscape. From our resources, we chose to expand on a few topics, such as the impact of wetlands on residential communities, the cost associated with engineering and maintaining a constructed wetland, positive and negative factors of constructed wetlands, and the type of regulatory bodies that give approval to construct a wetlands. Although this is a relatively new concept, there is no shortage of information, especially in Canada. So, what is an engineered wetland? An engineered wetland is basically a man-made swamp. You would typically find them on industrial and commercial sites, although they are starting to make an appearance in residential and even reclamation plantings in the oil and gas industry or mining. Some common pseudonyms for engineered wetlands are reed beds, soil infiltration beds, treatment wetlands, constructed wetlands, and man-made or artificial wetlands. These photos here show a constructed wetlands from planting to 2 years later. So on the left is the initial planting and design of the wetland, and then on the right is 2 years after when the vegetation is thriving. In this image, we see a constructed wetlands that is used to mitigate and dilute pollutants from a septic tank. So on the top image there's a septic tank on the left with a pipe leading into a zone of gravel. And then after the gravel, there is an area with the plants, and so the pollutants that would be carried in the water would travel through the root zone, being diluted from the plant roots. And then there is another area of gravel at the end to kind of modify or regulate the amount of water being let out at one time. And then there is a drainage pipe to lead away from the initial septic tank. So why are constructed wetlands applied? The most important reason for creating a man-made wetland is natural filtration of water runoff before it re-enters the watershed. Having selected plant materials that have water cleaning capabilities that are planted in and around the wetlands in such a fashion that when the water flows out of the naturalized area, it'll become cleaner. This also creates a home for multiple species of native and migratory animals, such as fish and birds and other water-loving animals. And in the case of a major rainstorm or flooding, wetlands also create a buffer zone for the water to flow into, helping minimize the overload of a storm drain. Because naturally water sits in all kinds of locations, and previously we have added soil and removed the water. Now we know the importance of keeping water locations to benefit the ecosystem. So here are some benefits of a constructed wetlands. Basically, runoff from contaminants such as fertilizer, chemicals, and garbage hurt everything in the ecosystem. So by controlling the flow of the water and filtration through wetlands, it decreases the negative impact, basically. When a flood happens, the water is attracted to the wetlands and migrates there, potentially causing less damage to residents, flooding and such. And instead of having a water cleaning station, it can be naturally done for a fraction of the cost while supporting wildlife. So how do you get approved? To be approved for a wetland, you need multiple permits, both from the federal and provincial government. Some of these are the Canada and Alberta Water Acts, respectively, the Alberta Fish and Wildlife Act, City Council approval if it is a residential construction endeavor, and individual construction permits as well, and many more depending on your location. So some of the challenges or potential downfalls of a constructed wetlands. One of the main downfalls is the amount of space required for an installation, which can quickly add up in cost, especially in an area where real estate is very expensive. There's also a large number of regulatory bodies that need to give the go-ahead, like the last slide mentioned. This can result in projects taking upwards of 10 years to even get started, as we saw in Stantec's ongoing Cornerstone project. So once a constructed wetlands is completed, it may take some residential education of the citizens that will be occupying the space in order to keep it functioning as intended. This education might include things like telling people to stay on the path and not to damage the fragile ecosystem, not letting their dogs run off leash and hunt birds or their cats, and using the correct amount of fertilizers on their private yard spaces, and not mowing areas that are deemed to be part of the engineered native grasses. Wildlife impact. Constructed wetlands provide a diverse ecosystem that can sustain many forms of life, from aquatic to avian, terrestrial to insect. It encourages growth and stability of many life forms, including plant varieties, aquatic insects, some of which purify the water to a small extent, fish life that can also purify the water, and birds that add visual appeal and play a vital role in the ecosystem. Also amphibious creatures like frogs, snakes, and other small reptiles, and small mammals like beavers or muskrats. Maybe you'll get lucky and see a moose tromping through the swamp from time to time. The wildlife impact of a constructed wetlands ideally results in a healthy, cohesive ecosystem that provides adequate conditions for life, therefore encouraging mating and nesting in every level of the food chain, from insects to humans. This constructed environment would otherwise be a slab of concrete or a field of grass, whereas this alternative encourages a diverse range of life forms to thrive where otherwise they would not exist. Community impact. Some of the immediate impacts of a constructed wetlands is the fact that residents can interact with the area as well as their fellow humans and canines. Constructed wetlands create a lovely naturalized area that is ideal for an afternoon stroll to observe the wildlife and escape into an area that is not seemingly urban. There is also a benefit to the soil in the sense of groundwater retention as well as diverse plant life that can work symbiotically with the ecosystem to filter out unwanted trace materials like metals, microplastics, and excess fertilizer. One of the other immediate benefits to the urban stormwater systems, as the constructed wetlands will hold much more groundwater in their natural aquifers than a traditional urban park space. This provides relief for the local stormwater systems that may otherwise struggle in situations like heavy spring snowmelts and other potential flood scenarios, adding huge value to the community residents. And now we'll get into some different types of engineered wetlands. So the first one is subsurface engineered wetlands, which is usually used in waste treatment. So subsurface wetlands involve the wastewater being filtered below ground, generally under a layer of gravel and or sand. The benefits of this system include efficiency of waste breakdown. It does not attract mosquito nesting where above ground wetlands would. It is less odorous than the above-ground systems, and they are less sensitive to winter conditions. One of the downsides is that the wastewater intakes can become clogged with the gravel, and that's mitigated by using larger-sized rocks at locations around the entrance, and then gradually reducing them throughout the system. So subsurface is also broken down into two subcategories, horizontal and vertical. Horizontal is generally easier to install. It works with the natural lay of the land, but takes up more space, more square footage. Whereas vertical is straight up and down, that takes up less square meters, but requires air pumps to aerate the bed, and is just like a slightly more complicated installation process. And then there's surface wetlands that mostly for stormwater control and water purification.
Design and planning considerations. The following guidelines can help ensure a successful project. Ensure that the design focuses on function rather than form. Try to design with the landscape as much as possible, taking advantage of natural topography, drainage, flora, etc. Try to design for self-sustainability. By reducing maintenance and monitoring as much as feasible, we can encourage long-term success. Be aware of freezing conditions and the impact it may have on the wetlands. Ice buildup, high water, and spring thaw are some of the natural cycles that must be allowed for. There are also site-specific factors which must be taken into consideration. This would include things such as soil suitability, hydrology, vegetation, and presence of endangered species or their critical habitat. Knowing these will help mitigate unintended consequences of wetland installation. Also, make sure your long-term plan includes regular inspection, monitoring, and maintenance. Lastly, consider the role of the wetlands within the watershed. What potential water quality impacts may it have, and what effects it may have on surrounding land use or local wildlife. When choosing vegetation, selection needs to accommodate the hydraulic operations of the wetland system and still support habitat objectives. Take into account items such as water quality or wildlife habitat. In general, use a diverse selection of native locally obtained species. You should obtain seeds from a local seed bank or seedlings from a local nursery wherever possible. Native plants from existing wetlands may be harvested provided that the removal of the plants does not result in damage to the existing wetland or violate any applicable laws. Finally, the use of weedy, invasive, or non-native species should be avoided. When developing a constructed treatment wetland, you should consider its role within the watershed as well as within the broader ecosystem context of the region. Aspects to this role include potential water quality impacts to surface waters and groundwaters, things like physical, chemical, biological, and thermal impacts, surrounding and upstream land uses, location of the wetland in relation to wildlife corridors or flyways, potential threats from the introduction of non-native plant or animal species, and also the local citizens' perception of constructed treatment wetlands in their area. Based on the Canadian climate normals, the monthly average temperatures indicate that, for a seasonal discharge system, treated wastewater can be discharged to the wetland from approximately April to October, since average ambient air temperatures are above freezing. Wetland systems can be operated through the winter months, but must be over-designed to compensate for the reduced contaminant removal rates during cold weather operations, particularly for nitrogen concentration reduction. Year-round systems require additional land area as compared to seasonal systems. In climates similar to that of many parts of Alberta, year-round treatment wetland systems have been installed and have demonstrated high removal efficiencies. Wetland construction costs are determined by the cumulative costs of land, earthwork, planting, design, monitoring, and maintenance. Special architectural features that are incorporated into the wetland design may make it a more attractive feature for surrounding community, but may increase costs significantly. The type of system built can change the price drastically. The high cost of gravel fill can raise the price per hectare of subsurface flow wetlands to as much as about 4 times the cost of surface flow wetlands. However, subsurface flow wetlands can handle greater contaminant loading rates than surface flow wetlands, thereby reducing the land requirements.
This next slide discusses the fact that, yes, you can be legally liable by your client or third person parties if your project increases erosion or flood hazards on adjacent lands by obstructing flood flows in the wetlands. The flood hazards are not an infrequent accident during construction. If flood hazards occur, courts have held government units and individuals liable under a variety of legal theories. There's no easy way to define constructed wetlands by numerical value. You need to identify the overall type of wetland and its location, and that can suggest particular function and values. But knowing overall wetland type will not provide a detailed picture of function or values. The most common method for assessing individual functions and values is to visit the wetlands and assess possible functions on a function-by-function basis based upon observed characteristics of the wetland and surrounding lands and waters. Sometimes it's difficult to locate the boundaries of a constructed wetlands. It depends on the location. Most wetland boundaries are easily identified, but if the boundary is close to something like a river line, maybe some bluffs, a steep bank, or a narrow transition area between wetlands and uplands, then that boundary might be a little bit difficult to decide where it begins and where it ends. They're often difficult to determine whether subsurface drainage has occurred, and the condition and effectiveness of the drainages are unclear. Finally, wetland boundaries are often difficult to identify where urbanization, agriculture, and other watershed conditions have dramatically changed the natural hydrology of the land. In conclusion, we have decided that engineered wetlands are a lot of work, but they're worth it. And thank you for listening to our presentation.